Okay guys, so today we are going to see the SAT question that nobody could apparently solve. Why? Because none of the options for this question are correct. So the channel Veritasium already made a video on this question, but it was too long, so I have brought the exact answer to you. So basically what's given in the question is that the radius of this circle A is 1/3 to that of circle B. Alright, and we need to find out that how many revolutions this circle A will take around circle B so that its center comes back over here. So basically how many times this will roll over circle B so that the center coincides with its starting point. Okay, so we need to find this. So now how are we going to solve it? Instinctively what you will think of, the answer is 3. That's what everybody thought of and most of the students marked in the SAT exam. Why? I'll give the logic to that. So from this over here which is given, you can say radius of A into 3 is equals to the radius of B. So let's take the radius of A as 1 unit. So radius of B will be 3 units. Okay. So this is 3 units. This is 1 unit. Okay. Now if you take out the circumference of circle A, then you will get 2 pi. Right, because the circumference is 2 pi r and radius we have taken as 1 unit. So you get the circumference of circle A as 2 pi, but of circle B you will get 2 pi into 3, that will give you 6 pi. Alright, now what you will think of dividing 6 pi by 2 pi, that will give you 3, right? So most of the students marked 3 and the evaluators also thought that 3 was the correct answer. But this is not the correct answer. The correct answer is something else. So basically what you have to find out is the position of the center. Like basically when the center will come back over here. So let's see what path the center has to travel through. The center, if it starts from here, it will have to travel like this. Right? So the center will travel like this. Right? The center will travel like this. Alright, and so basically the center is also traveling in a circular trajectory, right? And what is the radius of the circular trajectory? It's 3 plus 1, because both of these circles touch each other, right? So it's 3 plus 1, that is 4. So this circular trajectory of this circle, or basically this point that has to, like this point will go in this circular trajectory, right? So this circle through which this point will travel has the radius as 4 units. All right, so let's find out the total distance this point will travel. That will be 2 pi r, that is equals to 2 pi into 4, that is equals to 8 pi. So this point will have to travel 8 pi distance, right, to come back to the same point. Now in one revolution, this every revolution this circle is making over here, it is covering 2 pi units of distance, right? So every revolution this circle is making over here, it is covering 2 pi units of distance, because that's its circumference, right? So what we'll do, we'll divide 8 pi that the center has to travel divided by 2 pi, the distance that is being traveled in every revolution, and this gives us 4, right? So this gives us 4. So basically this smaller coin over here and this bigger, like we had 2 coins, this is the bigger coin, this is the smaller coin, and smaller coin will have to make 4 revolutions to actually, so that the center coincides with the point from where it started. Alright, so basically to sum up, we found out the circular trajectory of the center point of the smaller circle, that is this, which is 3 plus 1, has a radius of 4, right? So the distance exactly what the center has to travel is 8 pi, and the distance that is being traveled in one revolution is 2 pi. So 8 pi divided by 2 pi gives us 4. So the correct answer is 4. Okay, 4 is the correct answer. None of these answers are correct. 4 is the correct answer. I hope you liked the video. If you did, please leave a like.